This is a fully automatic 3D printed catapult that can shoot 5 balls in a row. I had this idea a long time ago and I finally got to it. In this video I will guide you through the whole process and improvements I did to make it work, so let's get right into it. So here is the plan. I need a few rubber bands as the energy source to rotate the arm of the catapult, and also another one on the other side to slow the arm down at a specific angle so that the ball can leave the arm. After shooting, I need a winch mechanism which will pull the arm down again with a thread. To stop the winch mechanism, I will use a micro switch. Before shooting, I need to loosen the thread so the arm will be held in place by a servo. To make it fully automatic, I also need a ball feeder which will be able to reload the catapult multiple times. So that's the theory, now let's start with the real thing. Here is the first version. I expect a lot can go wrong, so I made the sub-assemblies attachable to the main plate so I can replace them easily. Also, I left the ball feeder for a bit later as I want to test if it works at all. So when the arm comes down, it is guided by this part and locked with a servo arm. Here is the mechanism which will pull the arm down, which is basically a 360 servo. I also made the position of the second rubber band movable to be able to control the vertical position where the target is hit. So let's print it out and see. Here is the first prototype and definitely not the last one. I used a thin wire instead of a thread to load the arm. After loading, the wire is made loose again and it can be shot with the right button. However, the distance it can shoot is barely over 1.5 meters or 4 feet. I need to put a lot more energy into the system, so I have to redesign the rubber band connection. But the main problem is the loading mechanism. Even though the wire is loose before shooting, it still keeps on hanging sometimes and takes energy from the arm and makes the whole thing less precise. So a completely new idea of loading the catapult is needed. So after rethinking the loading mechanism, I came up with this. The same servo is used, this time it is connected to the gears with a total ratio of 1:12, so the main wheel will have 12 times higher torque than the servo. The idea is that the main gear will push the arm down until it presses the micro switch, then the arm is locked in place as in the previous version, and the main gear will rotate back. The rotation will be stopped by this second micro switch. Now the arm can freely shoot without the wheel in the way. I also changed the connection of rubber bands to the arm, so I can use more of them. Based on some rough calculations, the rubber bands can pull with 60 newtons and the loading mechanism should still work. So now again a lot of printing and I'm curious if this will work better. So here it is all assembled. The loading mechanism works great and had plenty of torque. However, the ball still leaves the arm too late and the rubber band that should slow the arm down at a certain angle doesn't work properly. So I printed out 2 holders between which a rubber band would be placed to slow the arm down more intensively. But the issue is still there. I even tried to do some slow-mo with my phone and as you can see the ball leaves the arm basically horizontally. Now I could solve the problem by inclining the whole catapult by 45 degrees, and maybe I will incline it a bit at the end, but the problem is that the arm is evidently not designed properly, so I will first try to do some changes there. After looking into the old design of the arm, I adjusted a few things. The main change is that the whole arm is sort of bent. I realized that the ball tends to leave the arm when the shorter part is approximately in this position. But here the head of the old arm was already too far and the ball went straight forward. When the shorter part of the new arm reaches this position, the ball will still be in upward movement. I did lose a lot of distance where the rubber bands pull the arm, so I redesigned the position of the release mechanism and the micro switch, so the arm can go as close to the main plate as possible. And as you can see, the new arm is a lot thinner and lighter. I did some simulations to avoid weak spots, I changed the rubber band connection so no screws are needed, and I printed it divided into 2 parts, which I then glued together. After assembling, I noticed that the rubber bands weren't under sufficient tension, so I added this little additional part to get more force out of them. But finally, the change of the arm solved the angle issues. With this setup, I was able to hit the target in a similar area multiple times. Also, the slow-mo shows that the ball leaves the arm at the proper angle. Angle can be also slightly adjusted by changing the position of this rubber band. So now the last thing to make it fully automatic is the ball feeder. I think the best way to make it will be to use 2 servos. When the first servo will open, it will only let 1 ball through, while the rest stays in place. After the first servo is back in the initial position, the second servo will open and let all remaining balls move forward. In this way I can be sure that only 1 ball will be let through each time. I also added this part, which will guide the ball and prevent it from missing the arm. I printed the parts, built them together, and surprisingly the ball feeder worked right away. So now I adjusted the Arduino code to include the ball feeder, and here is the whole catapult built together. I made it in a way that the upper servo is initially open so that all 5 balls can be inserted to the ball feeder, and after that it's closed. Then the arm is loaded, and when it's locked in place, ball is loaded and can be shot. Alright, it works great, but the goal was to make it fully automatic, so I adjusted the code again. The whole loading and shooting sequence is defined here and runs in a loop 5 times in a row. I left only 1 button on the breadboard, which will trigger the sequence. And here is the final thing. As before, ball feeder is filled up, but now, after pressing the single button, everything runs automatically. I tried to reduce the cycle time to minimum, so the ball is shot as soon as it stabilizes in the arm. At the end, I wanted to compare my and Catapult's skills. Here is the Catapult shooting 5 times on the target. So 1 ball missed the target by a bit. I tried the same thing by myself and I was able to hit it 5 times, but I would say that the precision is quite similar. So after all, I guess the project was quite successful, although I think there are still a few things that could be improved, especially when it comes to aiming and precision. That's why I am planning to do a second video about this catapult in the future, so stay tuned. That's it for today. If you would like to support the Thought to Think channel, you can like, subscribe or even share the video. Thanks a lot for watching and see you next time.